Okay, so this should be the last page of your packet here, and we don't have too much to do, and honestly it's nothing new. Like I'm not adding anything in new. I'm not teaching you another law today. We're still just using law of sines, law of cosines, but we're kind of combining them together in order to solve triangles. So I mentioned this yesterday when we went over law of cosines notes, that there's going to come a point in time where they're going to give you a triangle and they're maybe going to want you to figure out anything that's missing, so any sides or any other angles that you need to find. And we might have to use a combination of law of cosines and law of sines to get that done. So we're going to go over a couple of examples. One of them, on the first one, is just kind of describing a triangle to you. The second one is taking it back kind of to those real world examples like you've been seeing on some of your worksheets, of applying it to a situation. And so for both of these, we're going to want to draw pictures first of our potential triangles that we're working with here, and then start finding whatever might be missing. So this first one says we've got triangle ABC. It's described below. So I'm just going to start out by sketching a triangle, and it doesn't really matter what it looks like. And I'm going to just label that A, B, C. They want us to sketch a picture and find the missing measurement. Round the side measurements to the nearest tenth. So I'm going to underline side measurements. They want to the nearest tenth. And they want angle measurements to the nearest degree. All right, so let's come down here to my picture and let's figure out what goes where. So this is saying that B is equal to 6 feet. So where on my picture should I put that? Opposite of big B. So would that be on the bottom of my triangle for this one? So we're going to put 6 feet here. Where should the 19 feet go? On line BC. And then 17 should go on AB. Very good. What are we looking for this time? Measure of angle A. So this is what's missing. That's what they want me to find. So this is kind of using what we talked about yesterday, because we have the side, side, side case here. And like what we did on our bell ringer today. So how would you set this up?
6 squared equals 17 squared plus 19 squared.
Do we start with the 6 squared?
I don't remember. I think so.
What angle are we trying to find?
Oh yeah, you're trying to angle it.
So what side should we start with?
19.
The 19, because we always start with the side that's across from the angle that we're looking for. So we're going to start with the 19 squared. And then we're going to do 6 squared and 17 squared. Okay, what comes next in my law of cosines formula? Good, and then? Good, cosine of A. Okay, I'll give you like a minute or two there to try to work through that. If you don't have a calculator, I would go grab one. All right, I went ahead and got it kind of started up here on my screen. I just squared those numbers and I multiplied what I could. What'd you guys do next?
Added 36 and 289 and subtracted that from 361.
Okay, and when you subtracted it over, what did you get?
36.
Okay, then what would we do?
Divide by negative 204.
Okay. Whoops. Okay, so these are gone. What'd you get for a decimal here?
Negative 0.17.
Everyone agree? Yeah. And then what'd you guys do for the last step?
And I put that in the inverse cosine thing.
Okay, so angle A came out to be about what? They want it rounded to the nearest degree, so a whole number. 100. Good. Okay. Next one is similar. We're going to need to draw a picture here, but they're also giving us like context behind what's going on. So it's not just saying, here's these measurements that you can put on your triangle. We'll have to read through the problem and kind of figure out what needs to go where. All right, so down here, I'm going to start out the same way. I'm just going to go ahead and draw a triangle that I can kind of use to help myself out here. So it says, Carl and Jen are standing on a basketball court 60 feet away from each other. So let's just take this sentence by sentence here. Where could I put like Carl and Jen at? Opposite on the bottom. So could I put like a C here for Carl and a J here for Jen maybe? And how far do we know they are from each other? 60 feet. So I'm going to put 60 in between them. Okay. They are trying to figure the height of a speaker hanging between them above the court from the ceiling. Carl uses his clinometer, which is the tool that you guys used in the gym. Okay, those angle finders. And sights the speaker at a 70-degree angle. Where should that go?
Right under the, like, angle.
Parker, what do you think?
The corner by the J.
By the J?
Yeah.
Are we talking about Jen right now?
No.
The C. So I think it should go over by C, right? It's Carl, and he's looking up at the speaker. So it'd be like an angle of elevation. So the 70 degrees should come down here by Carl. Okay. While Jen sights the speaker at 30 degrees. So where should the 30 go? By J. Okay. Carl and Jen are both 5 feet tall. How far off of the gym floor is the speaker hanging? Round to the nearest foot. So let's call up here S for speaker, because that's where the speaker would be. And we want to figure out how tall it is. So I'm thinking about the height, which is actually going to be on the inside of this triangle here. Because remember, height would be from where it is, like straight down to the floor. So if they were going to use like just a regular sine, cosine, or tangent function like you guys did a couple weeks ago when you were in the gym, someone would be standing underneath the speaker. But neither of them are directly under the speaker, it looks like right now. So I do want to figure out what this is eventually. I'm just going to put an X there. Okay, and then let's just try to fill in what else we know. If we know that the bottom two angles are 70 and 30, how much would that leave for the angle at the top of my triangle? 80. So I'm going to go ahead and just write that in here. This would be 80 degrees. All right, so I ultimately want to find X on the inside there. When I drew this picture in, that height in here, what kind of triangle did I create? A right triangle. So what I might want to do first is figure out how long one of these two sides are, either between Carl and the speaker, between Jen and the speaker, and then I can go back to just looking at a right triangle and using some of my properties from the last unit with just regular sine, cosine, or tangent to figure out that X. But we're going to have to start with either law of sines or cosines to figure out one of these two sides of the triangle. It doesn't really matter which side we look for. Like I'll call this side little j, and I'll call this side little c, because those are opposite of Jen and Carl there. So would you guys like to find Small j or small c?
Small C.
Small c? All right, so let's figure out how we're going to do that. Now, I have all my angles in here, which means I should be able to use law of sines. I'm not forced to use law of cosines in this situation. If I started to use law of sines, how could I potentially set that up? Sine of what over what equals sine of what over what? Yep, so think about the picture here. What would we maybe use for like big A and little a? 70 and what goes with the 70? Little c. That's what we said we wanted to find, right? Now on the other side, I don't want any variables. So I need sine of another angle, and I need the side that's across from it.
Sine 80 over 60.
Very good. You have to use the 80 and the 60 because we don't know what the other side is. So I don't want to use little j because then I'd be stuck with two variables, my problem here. How do we solve something that is written like this? Cross multiply. So we'd have 60 times the sine of 70 equals c times the sine of 80. What would you guys do next? Good. Okay, we got to use our calculator here. We're going to plug this in. 60 times the sine of 70. And then you're going to divide that by the sine of 80. This will get you little c.
57.25, so like
0.3 you said?
Yeah.
Okay. And that would be feet. Okay, so this side here is now 57.3 feet. You could have set up a similar proportion using law of sines to find small j if you wanted to instead, and then you would use that other side of the triangle. Since I have that 53 or 57.3 here, and I've got a 30-degree angle, and I want to find my x, I'm going to kind of isolate my thinking right now. I'm going to highlight to this triangle. Okay, so that yellow triangle that I just highlighted over, that's a right triangle. I want to use that to help me solve for the height of the speaker. If you need to, you could separate this out and draw another little triangle down here where this is what we're missing. We just found this to be 57.3 feet. We know that this angle is 30, and we know that that one's 90. Okay, how could I set that up? Think back to last unit, regular sine, cosine, tangent. Which function could I use for this new triangle? 30 is your reference angle.
Like cosine or something?
Sine, why sine dash? Yeah, this is opposite and this is hypotenuse. So think about SOHCAHTOA from last unit, that's sine. So how would we write that? Sine of what?
30.
Equals
X over 57.3.
how would you solve for x?
Times by 57.
Okay, go ahead and calculate that. 57.3 times the sine of 30.
28.65.
Okay, let's round it to 29 feet. Are we finished, or is there anything else that we need to take in consideration here? Their height. How tall did the problem say they were?
5 feet.
5 feet. So remember when we did this in the gym, when you guys were standing and you were measuring your angle, we talked about how you have to add your height in unless you were laying on the floor. Neither of them are said to be laying on the floor doing this, okay? They're both standing, it says, so we have to add the 5 to it. So how tall is that speaker? 34 feet. Good. Questions on that one? That was a little more involved because we used law of sines And then we went back to what you guys would have used in the last unit, still talking about trig, just going back to our right triangles.